Hi, my name is Robin Sanders, and I'm your instructor for Calculus 1 this semester. In this video, I want to give you a little bit of background information about myself, as well as some information about the course and about what calculus is all about. First, let's start with myself. I've been teaching at Buff State since 1997, and I'm a former department chair, among many other things. I got my PhD from the University of Illinois at Urbana-Champaign back in the 1990s, and I've been teaching calculus in one form or another since the spring of 1981 when I was a brand new graduate student at the University of Illinois. Calculus teaching's come a long way since the early 1980s. Back then, there were no graphing calculators or any other forms of technology, so everything had to be done by hand. That's not true today. I got my first experience in teaching calculus with technology in the 1990s when I was able to participate in a project called Calculus and Mathematica that was coming out of the University of Illinois. And it mixed using Mathematica, a powerful computer algebra system, to teach the concepts of calculus. The textbook that we use for this particular course is called Calculus from Graphical, Numerical, and Symbolic Points of View. And it is another calculus book that came out of an NSF project back in the late 1990s, early 2000s. And while the book is out of print, we've continued to use it here at Buff State. It has a very non-traditional way of presenting the material, and it does not read like an ordinary math book. And I hope that you actually enjoy this book because I do have reading assignments sprinkled throughout the Blackboard site for the course. So that's two of the things that I'm wanting to kind of let you know about. The final thing that I want to talk about in this video is a little bit about what is calculus itself about and where does it come from. Well, briefly, differential calculus, which is what Calculus 1 is all about, is about one main problem, which is generalizing the idea of rate of change from a straight line. The rate of change in a straight line is just rise over run, and it's constant, to other functions, functions that are not straight lines. So if we talk about a parabola, y is equal to x squared, how is that changing? What's the rate of change? Well, it depends upon where you're looking at it. And differential calculus is all about rates of change. And because it's about rates of change, it's extremely useful in all areas of science, as well as many areas of social science, and in particular economics and psychology and courses like that. Well, where does calculus come from? Well, that depends upon a little bit about how you think about mathematics. There are two founders of calculus. They are Isaac Newton and Gottfried Leibniz, and they both developed calculus independently of each other in the late 1600s. Newton published his work first, and in fact, when Leibniz published his, he was first accused of plagiarism. And it was later figured out that no, he did not plagiarize Newton. He developed the ideas independently of Newton, even though they are, by today's standards, more or less the same ideas. One thing that is important to realize is that Newton was developing his ideas primarily as a physicist interested in studying how things moved through space. The basic story of how he thought about gravity when an apple hit him on the head, which is probably not true, but it's a good myth. And he was also interested in looking at how planets moved around the sun. And some of his ideas were based on ideas that Johannes Kepler had developed in his work dealing with planetary motion and in figuring out the area of ellipse. But both Newton and Leibniz were interested in figuring out how a mathematical function changed. And they developed their ideas through the use of something that we now refer to as infinitesimals, the idea of something being infinitesimally small. And that itself posed problems for mathematics. And so The calculus is finally put on what is considered a rigorous foundation in the 1800s by mathematicians like Cauchy and Riemann, among others, and Weierstrass. It turns out that when we study Calculus 1, the notions of Cauchy and Weierstrass are not all that important. We will touch upon them when we look at the formal definition of the limit. But most of what we will be studying in this class is actually pretty much directly due to Newton and Leibniz. Newton's notation, outside of some elegant notation for denoting the derivative, was kind of awkward and weird. Uh, Leibniz thought a lot more about notation, and the notation that he developed for the calculus is actually become pretty much the standard notation for derivatives and other ideas in calculus. And much of the time we will be using Leibniz's notation, or we'll be using Newton's notation with modifications that are due to Leibniz. The final thing that I want to say is that most of you are not math majors. Most of you are science majors of one sort or another. And it's important to realize that your home department is requiring you to take calculus because calculus represents the language that scientists use to describe the way whatever it is that they're studying changes, primarily with respect to time. So I hope that you will enjoy the semester, and I hope that you will work hard, because if you do work hard, you will be able to get a good grade in calculus.